In this video, I'm going to talk about something very interesting, which is the upcoming React compiler for React 19. And I was really surprised when I saw what this does, even though I never used any workarounds. I never needed even what was used before. But anyways, in the last few videos I talked about use memo, and I played a game to test my understanding of use memo. So let's just quickly recap what is use memo. So I asked Gemini to explain in simple terms. So in React, components often re-render. This can be good, but sometimes it can cause performance issues if you have complex calculations inside your component. So I'm using Gemini because it will explain better than I can, and it will also help me understand it better. So anyways, if for example we have some complex calculations that we do not want to render every time for every single change in similar place. Anyway, let's just go and read. Use memo helps by remembering the results when you first calculate something, and when you first calculate something, use memo stores the result, avoiding recalculations. If the inputs of your calculations haven't changed, use memo gives you saved results instead of recalculating it. And there was a very good, actually I heard about this watching the React conference 2024. You can see it on YouTube. I recommend because it goes into the example of it and how it can improve performance. So here's the example. Imagine you have a component that shows a list of filtered items. Filtering the list is slow. You can use memo to store the filtered list and only recalculate it when the filter criteria change. If we did not use memo here, this filtered items, for example, let's imagine it this way. So the filtered items has a parent component, and if something change in that parent component, the whole component and its children would re-render. I think I found a way how to explain it. And use memo will block the re-rendering of the component where we applied use memo. So in the last video there was a game which I played that explains this perfectly. Anyways, so here in the React documentation, use memo is a React hook that lets you cache the result of a calculation between re-renders. Its usage is skipping expensive recalculations that do not change and skipping re-rendering of components. Okay, now this use memo hook is used for optimizations. But there is something entirely new that is coming in React 19, and basically we will never have to use memo again, because there something is coming called React compiler that will do this automatically. Now let's read through it, but I highly recommend you to watch the React conference 2024. I will find it now. Okay, so here it is, and this is the React conference on day one, and somewhere around 1 hour mark, actually right here, 1.6,
React compiler.
They're talking about React compiler, which automatically optimizes components and hooks. So, and they are giving the example here where developers are manually inserting this use memo into a components, but the React compiler will do it, all of it automatically, and it even improved some optimizations that humans made. It improved it even further. So, and there were some statistics like 3% or I don't know how many percents on Facebook and Instagram, which are very, very big websites. So anyways, let's read about this. This will be very important, I think, in the future for big applications. This will be used and it will be very useful. So this page will give you introduction to the new experimental right now as of July 2024 experimental React compiler and how to try it out successfully. So under the construction, this is not yet available. You will learn, okay, note, it's experimental. Okay, so, okay, so I will start here. React compiler is the new experimental compiler that we've open sourced to get early feedback from the community. It is a build time only tool that automatically optimizes, so it automatically optimizes your React app. It works with plain JavaScript and understands the rules of React, so you don't need to rewrite any code to use it. This is also amazing, so we don't need to rewrite anything. Basically, we just run one command, and that's it. The compiler also includes an ESL lint plugin that surfaces the analysis from the compiler right to your editor. The plugin runs independently of the compiler and can be used even if you aren't using the compiler in your app. We recommend all React developers to use this ESLint plugin to help improve the quality of your codebase. What does the compiler do? So big question. In order to optimize applications, React compiler automatically memoizes your code. You may be familiar today with memoization through APIs such as useMemo, useCallback, and React.memo. With these APIs, you can tell React that certain parts of your application don't need to recompute if their inputs haven't changed, reducing work on updates. While powerful, it's easy to forget to apply memoization or apply them incorrectly. It's easy to forget to apply memoization, or it's possible to apply them incorrectly. This can lead to inefficient updates, as React has to check parts of your UI that don't have any meaningful changes. So again, here we are talking about big applications that have many states, many components, parents, children, and so on. The compiler uses its knowledge of JavaScript and React's rules to automatically memorize values or group of values within your components and hooks. If it detects breakages of any rules, it will automatically skip over just those components or hooks and continue safely compiling other code. If your codebase is already very well memoized, you might not expect to see major performance improvements with the compiler. However, in practice, memoizing the correct dependencies that cause performance issues is tricky to get right by hand. What kind of memoization does React compiler add? Okay, let's read this, why not? The initial release of React compiler is primarily focused on improving update performance, re-rendering existing components, so it focuses on these two use cases: skipping cascading re-rendering of components. Re-rendering parent causes many components in its component tree to re-render, even though only parent has changed, and this is it. This is what I successfully explained earlier on my own. So yeah, this is the main thing. Re-rendering parent component causes many components in its component tree, its children basically, to re-render, even though only parent has changed. Okay, because the data in React is flowing from up to down. If the parent changed and has to re-render, naturally all of its children has to re-render. Not sure how it works in systems with two-way data flow, but anyways. Skipping expensive calculations from outside of React. For example, calling expensively process really large array of objects inside of your component or hook that needs that data. Okay, optimizing re-renders. React lets you express your UI as a function of their current state, more concisely, more concretely, their props, state, and context. React lets you express your UI as a function of their current state. Okay? In its current implementation, when a component's state changes, React will re-render that component and all of its children. Unless you have applied some form of manual memoization with useMemo, useCallback, or React.memo. For example, in the following example, message button component will re-render whenever friends list state changes. So friend list, we have friends, online count, use friend online count. If it's 0, return no friends. And in span, we are displaying the number of friends that are online. We are using map method. So each friend we want to return a component with the key ID and friend, okay? And then we have the message button. So message button will re-render whenever friends list state changes. Okay, so if this is changing, if our friends that are online, if it is changing, which is coming as a prop from somewhere else, if the number of our friends that are online is changing right here, the component will re-render, and since this message button is a part of this component, it will re-render as well. But what if this was some very expensive calculation and we have to re-render it every single time when just one number changes, our friends online number? React compiler automatically applies the equivalent of manual memoization, ensuring that only the relevant parts of an app re-render as state changes, which is sometimes referred to as fine-grained reactivity. In the above example, React compiler determines that the return value of friends list card can be reused even as friends changes, and can avoid recreating this JSX and avoid re-rendering message button as the count changes. Expensive calculations also get memoized. The compiler can also automatically memoize for expensive calculations used during rendering. Not memoized by React compiler, since this is not a component or hook. Function, expensive, large. Basically, this is expensive calculation. Memoized by React compiler, since this is a component. Table container, items. This function call would be memoized. So the data, and it is calling this expensive calculation, and it is passing this items here as an argument. However, if expensively process really large array of objects is truly an expensive function, you may want to consider implementing its own memoization outside of React. Because React compiler only memoizes React components and hooks, not every function. So maybe we can put a function inside a component so it would be memoized as well, I guess. React compiler's memoization is not shared across multiple components or hooks. So, if this expensive calculation was used in many different components, even if the same exact items were passed down, that expensive calculation would be run repeatedly, we recommend profiling first to see if it really is that expensive before making code more complicated. Let's open the profiling. How to tell if a calculation is expensive. So this is covering more the use memo, use cases, but I guess I'm gonna skip that because this React 19 will come soon, and then we will be able to ignore this and just use React compiler in most cases. All right. So what we go back. What does the compiler assume? React compiler assumes that your code is valid semantic JavaScript and tests that nullable or optional values and properties are defined before accessing them. For example, by enabling strict null checks if using TypeScript. If object.nullable property, code block open, object nullable property dot foo. I don't get this foo, or with optional chaining. Okay, so if exists, then this, and follows the rules of React. What are the rules of React? Okay, this is the next one, which I'm going to make a video about. React compiler can verify many of the rules of React statistically and will safely skip compilation when it detects an error. To see the errors, we recommend also installing ESLint plugin React compiler. Oh, okay. So this needs to be first ESLint React compiler. Okay, so we need this React compiler first before we can use this React compiler feature that is coming in React 19. Should I try out the compiler? Please note that the compiler is still experimental and has many rough edges. This is interesting, many rough edges, because they have said that they have used it they have integrated it for months in Facebook application and in Instagram, their biggest applications, while it has been used in production at companies like Meta. Rolling out the compiler to production for your app will depend on the health of your codebase and how well you followed the rules of React. Well, that's why it's important to make a video about rules of React as well and read them all. You don't have to rush into using the compiler now. It's okay to wait until it reaches a stable release before adopting it. That's exactly what I'm going to do. However, we do appreciate trying it out on small experiments in your apps so we can provide feedback. Getting started. In addition to these docs, we recommend checking React Compiler Working Group for additional information and discussion about the compiler. Checking compatibility. Prior to installing the compiler, first you need to check to see if your code base is compatible. npx React compiler, okay. This script will check how many components can be successfully optimized. Higher is better. Checked for strict mode usage. Having this enabled and followed means a higher chance that the rules of React are followed, and if they are followed, that means we can get more out of the compiler. And check for incompatible library usage, known libraries that are incompatible with the compiler. As an example, this is what we will get in the terminal when we run this command. Successfully compiled 8 out of 9 components. Strict mode usage not found. Found no usage of incompatible libraries. Installing the ESLint plugin React compiler. React compiler also powers an ESLint plugin. The ESLint plugin can be used independently of the compiler, meaning you can use the ESLint plugin even if you don't use the compiler. Okay, and this is how we install it. We run this command. Then add it to your ESLint config. Okay, ESLint config, we add it. The ESLint plugin will display any violations of the rules of React in your editor. So this is why it is useful to use this ESLint even if we don't use the compiler. It will check for rules of React. I guess even a normal ESLint will check for that, but maybe this will be better. When it does this, it means that the compiler has skipped over optimizing that component or hook. This is perfectly okay, and the compiler can recover and continue optimizing other components in your codebase. You don't have to fix all ESLint violations straight away. You can address them at your own pace to increase the amount of components and hooks being optimized. But it is not required to fix everything before you can use the compiler. Rolling out the compiler to your codebase. Existing projects. The compiler is designed to compile functional components and hooks that follow rules of React. It can also handle code that breaks those rules by bailing out, skipping over those components or hooks. However, due to the flexible nature of JavaScript, the compiler cannot catch every possible violation and may compile with false negatives, so you can make a bug. That is, the compiler may accidentally compile a component or hook that breaks the rules of React, which can lead to undefined behavior. For this reason, to adopt the compiler successfully on existing projects, we recommend running it on a small directory of your product code first. You can do this by configuring the compiler to only run on a specific set of directories. React compiler config, sources, file name, so we will put only one file name, and return that file name, index of, okay, and some code. In rare cases, you can also configure the compiler to run in opt-in mode, using the compilation mode annotation option. This makes it so the compiler will only compile components and hooks annotated with a use memo directive. Please note that the annotation mode is a temporary one to aid early adopters, and that we don't intend for the use memo directive to be used for the long term. Okay. When you have more confidence with rolling out the compiler, you can expand coverage to other directories as well and slowly roll it out to your whole app, of course. New projects. If you're starting a new project, you can enable the compiler on your entire code base, which is the default behavior, exactly. And this is what will happen in the future. I guess when they also optimize the compiler so that we don't get these false negatives that are talked here. So we start a new project and we immediately use the compiler, and whatever we write, it will automatically optimize that code. Usage, Babel. The compiler includes a Babel plugin which you can use in your build pipeline to run the compiler. After installing, add it to your Babel config. Please note that this is critical that the compiler run first in the pipeline. Okay. Babel plugin React compiler should run first before other Babel plugins, as the compiler requires the input source information for sound analysis. v.19. If you use v.19, you can add a plugin to v.19 plugin React. Okay. Next.js. Next.js has experimental configuration to enable React compiler. It automatically ensures Babel is set up with... Wait, I'm using Next.js. Next.js has an experimental configuration to enable the React compiler. It automatically ensures Babel is set up with Babel plugin React compiler, okay? Next.js canary, which uses React 19 release candidate. Install the Babel plugin React compiler. Next canary, what does this mean? Install Next.js canary. Then configure the experimental option in Next.js config. Remix, okay, remix is like deprecated. Literally the developer said it is going to sleep. So also this React config is where the developers talked that there will be no more use for remix because I forgot why, but they will include all the features of remix with v.19, I think. So I'm gonna skip over remix. Webpack, I'm gonna skip that as well. Expo, please refer to Expo docs. Metro, React Native. Okay. Oh yeah, React DevTools has built-in support for React compiler and will display memo badge next to components that have been optimized by the compiler. So here, when we open a console and we go to the components, we will see all the components here, like this, and right here, it will look like this. It will say memo here, and here it is using the forward ref, which is some of the new features in React 19. We will not have to use forward ref anymore because we will be able to pass ref as a prop. And here memo as well, and memo and memo. So this is how it will look like in the new React DevTools. Maybe it is already implemented. Maybe this DevTools that I'm using is already version 5.0. Okay, and this is it about the React compiler. Very interesting, very interesting. So I'm looking forward to it.